Hello, my name is Isaac Fredette, and this is my CPR for exam 1, and the question I'll be going over is question 6, and it is that there are infinitely many infinite charged planes placed as equals 1, 2, 3, and to the nth meters, with the surface charge densities on each surface being half of that on the previous ones, and that is shown right here. And I've illustrated that in my drawing as well that I drew before this at the same time. And the question is, what surface charge density would be on an infinite plane placed at z equals 0 meters for the electric flux density to be 0 for z less than 0 meters? So to start, we know that these electric flux lines are going to be normal to the sheet of charges. So that means that it will be in the z hat direction and the negative z hat direction. We can keep this in mind for later when we're doing our Gauss's law. Oh, and my Gaussian surface I've chosen is a cylinder. And we know that the surface integral of d dot ds is equal to the charge enclosed by the surface. So our surfaces are going to be the top plus the bottom This will be equal to rho sub s times ds. And then for the top, it'll be d dot a hat z times a hat z ds, because this will be the normal, plus the bottom, which will be d dot negative a hat z times negative a hat z ds, because it will be coming out the bottom in the negative z direction. And then this will be equal to rho sub s ds. This will come out to d of z times s plus d of z times s. This will be equal to rho sub s times s. Now all these s's will cancel out, so that we get 2d of z is equal to rho sub s. So then d of z is equal to rho sub s over 2. Now that we have our equation for our electric flux density for each sheet, we need to use superposition to add them all together. So d of 1 meter plus d of 2 meters plus d of nth meters is equal to 1/2 the rho of 1 meter plus rho sub s of 2 meters plus rho sub s to the nth meter. And with this equation, we can see that the sum of this for the electric flux is equal to 1/2 1 times 1 minus 1/2 to the nth power over 1 minus 1/2. And this will evaluate to 1/2. So these two will cancel out. This will go to 0. So that we get the d sum is equal to 1 coulomb per meter squared, which is then equal to 1/2 rho total, which is this. So that rho total is equal to 2 coulombs per meter squared. And we know that our surface charge, since the equation for the electric flux is just this for a sheet of infinite sheet, we can just use this again down here and say that they're equal, so that rho sub s is equal and opposite, I should say. Rho sub s is equal to -2 coulombs per meter squared, because this is what we will need our surface charge density to be in order to create an electric flux density to cancel out all the other ones, so that the electric flux for z is less than 0 is 0. So this will be our answer.